Our purpose for this experiment was to discover the precipitate of copper sulfate and potassium hydroxide while finding the limited reactants, and also the changes in concentration within all 8 test tubes, finding differences in precipitation. By using different amounts of copper sulfates for each test tube and the same amount of potassium hydroxide, we expect that there will be a difference in precipitation between each test tube. A chemical reaction is a chemical change that occurs on 2 or more substances combining and creating a totally new substance. In some cases, the product can form a homogeneous or heterogeneous mixture. In a chemical reaction, a formation of precipitate might occur at the bottom and can change the water color. But a problem which may occur is an excess amount in 1 or more reactants, which can seem unequal, but by using all the reactants up leads to the point of this topic, which is limiting reactants. In fulfilling this lab, we used 2 substances called copper sulfate and potassium oxide. To have each test tube reach the same height, we also added water. We set up 8 test tubes, numbered them 1 through 8, and used a buret to dispense the solutions with the right amount of substance. Using the buret, we dispensed 5 milliliters of copper sulfate into all 8 test tubes and added an increasing value of potassium hydroxide, starting at 1 milliliter and ending at 8 milliliters for each test tube using a buret, and eventually putting water into each test tube to have a maximum height of 13 milliliters. Finally, we mixed all 8 test tubes with a spatula to get all elements evenly distributed and waited 15 minutes for the precipitation to take part. After the 15 minutes, we seen that the precipitation occurred and we measured it using millimeters on a ruler. The observations we had on the test tubes after stirring it and during its precipitation state was that the first 5 test tubes rose steadily, while the last 3 tubes, the measurements were the same. We also noticed that the first 5 tubes had a much different precipitation characteristic than the last 3 tubes. The first 5 tubes looked as if there was blue powder on the bottom as of Raz apple fun dip, and the last 3 had a more darker and spread out characteristic to it. Our group's precipitation measurements were 2 millimeters, 4 millimeters, 7 millimeters, 15 millimeters, 23 millimeters, 23 millimeters, 28 millimeters, and 28 millimeters.
We concluded that CuSO4 was a limited reactant only because it was put on each of the 8 test tubes and was overpassed by the excess of potassium hydroxide, which can be concluded why there is not any more precipitation happening anymore. The precipitate in the lab was CuOH2 when we combined the reactants together. When finding the amount of KOH and CuSO4, we have to first start with what's given to us, which is 0.2 mole KOH and 0.1 mole CuSO4. So by using the molarity equation, which is M equals moles of solute over liters of solution, we found out the amount of space taken up in each tube. For KOH, there is 0.2 moles over 1 liter, and for CuSO4, there is 0.1 moles over 1 liter. For each test tube, we calculated 0.2 moles over 1 liter times the total number of liters that the test tube using has. By doing those calculations for each test, we noticed that the answer was 2 to 1. Finally, due to the test tube 5 having a perfect ratio, it would mean every other tube after it would have an excess of KOH, which will make it limited reactant. And in this case, all the tests after 5 all stayed constant and had the same precipitation.